The interior structure of the Earth is difficult to examine. Even the most ambitious efforts to penetrate the Earth have barely scratched the surface, reaching only a few dozen kilometers out of a total radius of 6,371 kilometers. Until recently, volcanic eruptions have provided the only proof of the molten material beneath the Earth's solid crust. Miners also noticed that temperature and pressure gradually increased as they reached greater depths. In 1909, scientists observed that seismic waves change speed and direction at certain depths as they pass through layers of different properties. Using this method, they managed to map the Earth's internal structure. The primordial Earth formed around 4.6 billion years ago. Due to cooling and rotation, substances in the gas, liquid, and solid states separated and became arranged in spherical layers according to density. These layers are called geospheres. Geospheres are grouped into outer and inner layers. The outer layers are the atmosphere, the biosphere, and the hydrosphere. The inner layers are the crust, the mantle, and the core. The atmosphere is the outermost layer. Composed of gases, it is the lightest of the layers. The atmosphere has no definite boundary. It fades into outer space at a height of some tens of thousands of kilometers. It can be divided into 5 distinct layers based on their changing temperatures. The boundary of each layer can be found where temperature inversion occurs. The thin outermost layer of the atmosphere is called the exosphere. Its temperature is around 1,000 degrees Celsius. The next layer of the atmosphere is the thermosphere. Its temperature increases with altitude, 800 to 1,000 degrees Celsius on average. This thin layer, consisting of ions and therefore also called the ionosphere, reflects radio waves. The layer below the thermosphere is the mesosphere. Its temperature decreases with altitude. The atmosphere's coldest place, the mesopause, forms its upper boundary. The temperature drops to around 100 degrees below Celsius here. The temperature at its lower boundary is around 10 degrees above 0 Celsius. Most meteors melt or burn up in the mesosphere. The next layer is the stratosphere. Here the temperature rises with altitude because of the ozone layer. The ozone layer absorbs energy. Consequently, its temperature rises. The temperature at the lower boundary of the stratosphere is around 56 degrees below 0 Celsius. The lowest and most important layer of the Earth's atmosphere is the troposphere. Its temperature decreases with altitude. This 10 to 12 kilometer deep layer accounts for approximately 80% of the mass of the atmosphere and holds almost all of its water vapor content. Most weather phenomena occur here. This is the layer where aeroplanes fly. The outermost of the inner layers of the Earth is the crust. The composition of the continental crust is more diverse and thicker than the oceanic crust. Its upper layer is rich in silicates, while its lower layer consists of higher density rocks which are rich in metals. The Mohorovičić discontinuity, also called the MOHO, is a boundary located between the crust and the mantle, where seismic waves from earthquakes are refracted. The mantle is divided into 2 zones, the upper and the lower mantle. The upper mantle extends to a depth of about 700 kilometers. Its upper layer is solid. Together with the crust, it forms the lithosphere. The molten layer located at the bottom of the upper mantle is called the asthenosphere. The lower mantle is composed of solid rocks. The amount of heavier, metallic components found in the lower mantle increases with depth. The mantle core boundary, called the Gutenberg discontinuity, is located 2,900 kilometers below the Earth's surface. Situated below the mantle, the core is also divided into two parts: the liquid outer core, consisting of molten metals, and the